Welcome to the Docs Who Lift podcast, where we distill and simplify the complexities of a healthy lifestyle, exercise, medicine, and weight loss. We're excited to bring you a podcast that's a prescription for clinical practice, scientific recommendations, and just real life. This is the Docs Who Lift podcast.
Hey, and welcome back to the Docs Who Lift podcast. I'm your host, Dr. Spencer Nadolsky, and I have my co-host, Dr. Karl Nadolsky Jr., and with us, we have someone that was supposed to be on the podcast a few months ago, a super expert on all things diabetes and diet, Dr. Nicola Guess. She's an RD PhD living across the pond, and we're not going to be talking about diet and diabetes today, which we'll have to have her on. We're going to have her on again, but there was a recent paper that came out that, of course, we got tagged in a bunch of times because people think we're artificial sweeteners shills.
Well, I was getting like text messages too from colleagues who are also, endocrine diabetes experts and know that we have, talked a lot about artificial sweeteners. So that it was like sudden, urgent.
So I wouldn't even call this it's not artificial. It's technically natural. So it's a non-nutritive, maybe sweetener. Maybe that's a better thing. But erythritol, there was a big splash on like med Twitter and nutrition Twitter, but then also in the media, basically saying erythritol is causing cardiovascular disease, and basically don't eat anything or drink anything with erythritol. And Dr. Guess was the first one to kind of do a little tweetorial about it on Twitter. That's where kind of things happen very quickly, and people can do breakdown. And Dr. Guess does a great job at doing that. So we're like, let's have Dr. Guess on here to break it down for us. So welcome.
I hope my voice lasts for this recording.
Yeah, you'll be fine. It's better than ours.
We can always, we sound like hell, and we can always, just start talking at each other and, incoherently. So
yeah, very good. So tell us a little bit, like, first of all, the abstract, you can't even tell really what's going on in the paper based on the abstract, because it does look kind of damning based on the abstract, but you clearly got the full paper, went through the methods, and then quickly did a little tutorial. What was it?
And start with the basis of what the heck is erythritol?
Yeah, what's erythritol?
Because it's different than the artificial sweeteners we've talked about before, because it's a sugar alcohol.
Yeah, so I think Spencer summarized it like it's a naturally occurring sugar alcohol. So it's found in some fruits, it's found in some fermented foods. So even if you didn't eat any commercial products and you just ate produce, you would still get some erythritol in your diet. Mm-hmm. And it's also worth mentioning, and the key thing and the key flaw of the paper is it's produced endogenously. Mm-hmm. So that means the body produces its own erythritol. Mm. And so you can imagine then that gets confusing, because if all you're doing, as they did in this paper, is measure how much erythritol is in the body, well, gee, how do you know whether it came from the body or whether it came from food? And if it came from food, was it fruits or was it,
And the key is that there were two major parts of this specific paper, right? They looked at a bunch of cohorts, right, if I'm not mistaken, and used their erythritol levels and correlated, again, that term correlation doesn't always equal causation, right? Correlate it to cardiovascular outcomes. And if I'm not mistaken, the baseline characteristics of people in those cohorts had a very high amount of cardiometabolic disease, especially, those who had the higher amounts of erythritol. Is that correct?
I mean, maybe let's take a step back. Let's imagine that all that they'd kind of done was measure erythritol, even intake, even if they'd done that. All they did was measure that exposure at one time. So in these cohorts, they were pretty small, and they were a very unique population. They only measured erythritol exposure at baseline. And then they followed them up to see what the cardiovascular outcomes were. So, when people kind of criticize the Nurses' Health Study or those other studies, and quite rightly, but they have data collection over time. So even within those cohorts, you can track what someone's exposure is in 1980, 1983, 1986. That's a strength. In this one, even if they'd measured dietary intake, it was one time and then boom, they're relating that to an outcome. But they didn't do that. It's literally how much erythritol is in your blood in these, as you say, very unique cohorts. I think the majority of them had heart disease already. They had 20% had type 2 diabetes.
A lot of hypertension, a lot of obesity.
Absolutely. Yeah. So they were people you would think would have a lot of oxidative stress. And why does that matter? And it's because we think one of the things that causes elevated erythritol in the body is oxidative stress. I mean, it's very poorly described. I don't think there's real agreement on what oxidative stress is. But let's say the kind of milieu that you get in the body when you've got cardiovascular disease or type 2 diabetes, you get these stress markers. And that seems to be associated with elevated erythritol. And as far as I know, and I'm not an expert in cardiovascular disease, but the papers I've seen, erythritol is considered, I think, a reasonable biomarker itself for predicting cardiovascular disease.
And that's where there's this other paper that was actually published, actually does a nice little review on erythritol, because it actually was published about the health benefits of it, but made sure to note that, hey, by the way, it looks like people with obesity, cardiometabolic disease at high cardiovascular risk do overproduce through, a dysregulation of their enzyme pathways, this erythritol, which might be a marker of disease as opposed to causing disease. So that throws a huge monkey wrench into this stuff.
Right. So then what you absolutely cannot tell in these very small cohorts, very unique cohorts, where they're not even measuring dietary exposure, is do they simply have, or is it the erythritol causing the cardiovascular disease? Or is it the cardiovascular disease causing the elevated erythritol? You cannot tell from these cohorts. And so what was remarkable to me was the way that it was sold in the abstract and the way that it was, the conclusions were written, and even more tragically, I think, the way it was described in the press, that they did as a slam dunk, right? Like, oh my God, I'm concerned. So when I saw the first analysis they did, and they said it was a discovery cohort, and they'd done this analysis and found this association. Now, in my head, if I were a researcher doing this study, I'd go, right now we don't know whether it's from the diet or endogenous. So, hey, why don't we try and find that out? But they didn't do that. All they did was repeated exactly the same, very flawed analysis 2 more times. And they didn't validate it in a healthy population. They did it in, again, another 2 high-risk populations.
Yeah. And then what they did to try to connect the two, then they had these very small numbers of a little intervention, right? And they gave them erythritol to show that their levels went up or something. And it was and then they somehow connected the cohorts, the unclear chicken or the egg, to this small little group of people that when they ingest erythritol, their erythritol went up. So they said, oh, well, that must cause
I'm trying hard
disease?
to hide my rage. Because so they had these 3 flawed cohorts. I mean, it could be a PhD chapter. It's a paper in and of itself. There's nothing wrong with investigating relationships, although that was very flawed. They then did some in vitro work, so that means they did it basically in cells. And I'm not a basic scientist, so maybe they're legitimate methods, but nonetheless, so much you discover in cells, you discover relationships between antioxidants and something else, never pans out in humans. So I am super skeptical of any in vitro work. So let's park that. But the authors then say, we then tested it in an interventional trial and we registered the clinical trial. And so I'm a clinical trialist. That's the research I do. And I'm thinking, great. Well, that's good. They've got this flawed observational stuff, but good for them. They're going to test it properly in a randomized control trial and come with, test it clinically. And that's what they kind of look like they'd registered. So what their trial registration had said was they're going to take 40 people. They're going to give them either xylitol or erythritol. In their clinical trial registration, it's not randomized, which is weird to me because it's the strongest method. So why wouldn't you randomize? But whatever. It would be bad enough if they just reported that data, but they didn't. In the paper, you get an N of 8. So they've reported the outcomes of 8 people. And even though the trial registration says they're measuring platelet aggregation in humans, they just measure erythritol concentrations. That's all they're doing. They're reporting the pharmacokinetic data. So, that's fine. They just measure 30 grams of erythritol consumption and measure how much erythritol appears in the blood. That's not terrible. And they then relate that to their observational cohorts.
Yeah.
Taken together, that's really weak data. It's hypothesis generating. Right?
It is hypothesis. And that's what, Spencer and I said. It's well, okay, it's interesting. It's hypothesis generating, but there's an extraordinary amount of extrapolation between 3 different types of, flawed study design stuff. It doesn't mean there may not be something to it, I guess, but it sure seems like it goes against what basic data we do have showing the potential benefits of erythritol rather than, say, sugar sweetened beverages or whatever. But hard to say.
So the interesting thing is, after Dr. Guess put this out there, I was like, okay, I need to brush up on my erythritol metabolism. So I did. I looked at that paper that was just published in 2022, literally just recently.
Actually, I think the publication date's actually 23, if I'm not mistaken. I think it was online ahead of print in 22. The one you sent me.
Yeah,
I think it's really recent.
It goes through very well about how hey, it looks like high levels of erythritol in the serum, the blood, are associated with cardiometabolic disease, and a lot of the cohorts that they looked at, they showed this before erythritol was even an additive. If I'm not mistaken, it wasn't that much in the food system.
Other than the natural
is what
which of course the naturally occurring food sources of erythritol are all almost definitively known to be healthful foods.
Yeah,
fruit, vegetables, cheese, stuff like that, right?
In Japan, I think population of intakes of erythritol are twice as much as they are in Western populations because of the fermented foods they have.
And yet, they seem to do pretty darn well with their cardiovascular risk.
Yeah, we should check ourselves because obviously it's just observational research, a bunch of stuff the Japanese do that's really healthy. But I think that the way to look at this is no single study on its own is ever a slam dunk. So there is a study showing that erythritol consumption in type 2 diabetes might help, for example, with vascular function. And that's a small study. I don't think there was a control group, so let's chill out about that.
Yeah.
For me, the key thing is about the messages we put out as scientists and healthcare professionals is wildly terrifying people and extrapolating about something based on this really, really weak data.
So, we're in these little Twitter DM groups together. It just so happens the author of this paper was the same group lab that came out with the data on TMAO and its relationship with cardiovascular disease. Nicola, do you know much about TMAO? So TMAO, trimethylene and oxide. Do you know much about this stuff, a metabolite?
I've read a few papers and I thought it was sort of not to ignore. But let me just say, I don't pick on people, and I didn't know who the authors were of this publication.
Yeah.
I just looked at the methods and was like, wow, this is such weak methods. And I was stunned that it was in Nature Medicine.
And there are a bunch of people on Twitter. I was really sad to see some pretty smart people basically tweeting out like, "Hey, it's time to start not to stop eating erythritol. Basically, stop eating products." And I was like, "Whoa, did anybody read this yet?"
The answer to that is no, because it was hard to get the paper anyways. We were trying to figure out the abstract.
Yeah.
We couldn't see the doses and all this stuff, and it's awesome.
I was like, what is going on here?
And can I just complain about Nature Medicine and Cell Metabolism does this? Methods are at the end of the paper.
Yeah.
And it's like a method for everything. I read the methods first, and if they're rubbish, I don't take any. I just kind of ignore the conclusions, right? And the method at the end. And I think this comes back to this stuff that we know, really strong evidence is bad for us. And we should have one voice as healthcare professionals and scientists about what those things are and about the strength of evidence. And like you, Spence, my mind was blown about intelligent people who should know better saying, "Oh, look at this paper." Some people were saying it's not a slam dunk, but I'm going to avoid erythritol anyway. What?
Yeah, it isn't. It was just kind of weird. I'm like, I can't even tell what's going on. And again, people were just tagging us, and I was like, I haven't even taken a look. I can't get the paper.
It was amazing how urgent these messages were to us.
Well, because the media picked it up.
Yeah, it was CNN. I think that really the media that picked it up, and God forbid that our news media does a better job of being reasonable with their titles and when they talk about this stuff. It's whatever is crazy.
What are some practical takeaways? I'm not going to tell people it's completely fine. It's probably fine. That is, if I had to guess, but from this paper, we just don't know. You can't make any.
It's probably fine. My view on all of these small additives. I mean, one that we consume them in such small quantities. And I mean, they might do some weird things to metabolism and some pathways. They might do some good things. My take, and I haven't read all the literature on all of the additive, all the sweetness and stuff, but everything I've read suggests they're probably innocuous.
Mm-hmm. Yeah. And, and it is, again, worth saying. So compared to, say, we did a podcast last year on non-nutritive sweeteners, I've published a review on it, a counterpoint to those who are concerned about them. This, I did not include erythritol because it is different. It's it's a sugar alcohol. It's a completely different sort of thing. And so I really appreciate talking to you about this because we haven't talked about sugar alcohols at all. The biggest issue I've ever heard about was, when you eat too much of them and you don't digest it and it goes out where it goes out, and then that water follows it and you can get a nice trickle of diarrhea with it.
Or almost like in that way, it's like a self-limiting property of these products. Xylitol.
So funny story. We used to have a meal replacement. We had a supplement company, and we had a meal replacement. We called it Lean and Complete, and it was sucralose.
Sweetened.
That was sweetening it. And then people were like, can you do a natural one? And I was like, we tried to do stevia. It didn't taste good. So they were like, why don't you use xylitol and use inulin? And you can put a lot of fiber. Anyway, we did it. It was like, this tastes pretty good. Unfortunately, I needed a gas mask every time I drank it.
Now, to be fair, 20% of people need a gas mask around Spencer anyways.
Yeah.
But this was a statistically significant increase to about 87% of people needed it.
Yeah. Well, including myself, I'm pretty sure. I need to go. I needed to
Well, that one time we found you passed out in your own room from
it. Nico's like, what's wrong with you guys?
I can tell you about this.
So, but the reason I did bring up the T-mouth thing is actually a very similar story. Is looking at cohorts and looking at and not understanding whether this is causation, reverse causation, and I think Dr. Guess gave a good explanation of reverse causation. Is it the chicken or the egg? What's causing what? Is it the cardiovascular disease causing the increases in cardiometabolic disease causing the increase in T-mouth or erythritol or anything like this? And you really got to tease it out and actually probably do. I mean, I don't know how you test this with a randomized controlled trial. How would you figure that out? Give somebody erythritol and see if they look at some of the biological plausibility, or would you find ways to decrease the amount of erythritol in their? I'm not exactly sure. I'm sure you're a clinical trialist. You would.
I mean, certainly. The ideal thing would be to take our patients who have high cardiometabolic risk, especially dysglycemia like diabetes, and then randomize them to xylitol sweetened whatever and
erythritol sweetened
or erythritol.
But then you would have to wait till they have events. That might not be.
Yeah. So we need the high cardiovascular risk people, and we need 5 years, and we need a lot of money.
Here's the wild thing to me: they were doing a trial. They weren't looking at serious cardiac event or cardiovascular events as an outcome. But their trial was, I think, looking at platelet aggregation or some kind of markers of platelet aggregation. Now, I've never measured that in my trials. But the wild thing to me is they submitted this paper in July of 2022. It just got published. Now, their trial is an N of 40. It was probably recruited for by October of last year, latest. They probably have that. Like, how would they not have that data?
Why were only 8 people of the 40 that was supposed to be in there? Why is it? I don't understand that. You would know better. You're the clinical trialist.
I'm a skeptic. I'm really cynical. Like, the problem with these journals is all researchers want to get into them, because if you're a young researcher and you get a first author paper in Cell Metabolism or Nature Medicine, that's your fellowship. That's you getting good funding to do research. That's you getting a good salary. So when you put those incentives in front of people, guess what they do? They do everything they can to try and get the paper into high impact journals. Now, I'm a cynic, and if I'm wrong, someone can punch me when I'm proven wrong. But in my head, if they had finished that clinical trial, and I don't know why they wouldn't have by now, and they had positive results in the sense that they showed in humans that erythritol at 30 grams a day leads to platelet aggregation or markers of platelet aggregation in humans, they would have published it.
Yeah. I don't know.
Why wouldn't you? Because that's a slam dunk paper right there. Because then you do have that observational research, you do some nice mechanistic in vitro stuff, and then boom, you've got a nice trial in humans to put the puzzle together. And in my head, I'm like, I wouldn't be surprised if they had that data. It didn't show what they thought. So studies are ongoing. And I think the editor of the journal should have said, guys, you've got that trial ongoing. Let's wait till it finishes. Come back to us. We'll look at the data and we'll consider whether we go ahead.
It's interesting. All right. Well, thanks for coming on. I mean, we really do need to have you to come on. I feel like we need a few part series on all, like, because you are like the leading expert about diet and type 2 diabetes, and I think you do some stuff with type 1 diabetes as well. So, and we like talking about that, and we'd love to have you on to chat about that as well.
Yeah, let's do that when my voice is better.
Yeah, perfect.
Sounds good. Well, yeah, thank you so much. This was great.
Very good.
Awesome. Nice seeing you guys.
Here's our outro.
This podcast is for entertainment and education and information purposes only. Remember, the physicians on this podcast are not your physician. It should not be considered professional or personalized medical advice. It should not be used to replace speaking with your physician or medical professional to discuss your specific health concerns. The topics discussed should not be used solely to diagnose or treat any condition. As a result, we are not responsible for any unwanted medical outcomes. The views and opinions discussed are of those of the host only and do not represent those of any other entities.